Hi guys, Mr. Wynn here, wanting to talk about Learning Target 6. Learning Target 6 is I can explain the structure and function of enzymes and their activities. So if you see the picture here, this is the picture that's on your test. Now, if we were to look at this, we need to determine what is these different letters, A, B, C, and D. So if we start with the first one, A is going to be your substrate. So if you guys remember in class, we did the substrate and we had different types of sucrose, or we had different molecules of sucrose, and that the molecules of sucrose were actually trying to find this enzyme. Now, this sucrose, or this substrate here, is going to find specific types of enzymes to bind onto, and notice that this is a very high specificity. So, if you have an enzyme that's not shaped in this way, it won't fit. So these substrates are going to be specific to a certain enzyme. So letter C is going to be enzyme, and then letter B is going to be your active site. So this is the area where the substrate will actually attach to the enzyme. Okay, so once it attaches to the enzyme, what happens is a chemical reaction will occur that actually breaks apart these hydrogen bonds. Okay, so this substrate is held together by a hydrogen bond. Once it binds onto the enzyme actively disassociates that hydrogen bond and causes these two products here to separate. So these right here are products. So again, as you can see, we have two pieces of a molecule. Now, so this is a single molecule, and eventually it's going to bind onto this enzyme, and then the enzyme is going to break apart these hydrogen bonds. Once it breaks apart these hydrogen bonds, the one molecule now becomes two different molecules, and they go off into their different directions. Now, this is going to be our enzyme reaction. So this reaction here, the one that's higher, that's going to be the reaction that does not have the enzyme. Whereas, as you can see, there's this dotted line here illustrates a reaction that occurs with an enzyme. Now, just like in any chemical reaction, you have to have a reactant and you have to have a product. So, we have a reactant on A, and then we have the products, or the product, at letter D. So, depending on whether or not you have an enzyme, it's going to require that much energy. Okay, so here's the energy, and as you can see, it requires more energy without an enzyme than with an enzyme. So the role of an enzyme is to lower what we call the activation energy. Okay, so this is the amount of energy it requires for a chemical reaction to occur. On letter 3, it says, without an enzyme, the reaction rate can best be described by which letter? So if you were to again take a look at this little drawing here, which is the one without an enzyme? Of course, it's letter B. Would this reaction be considered a hydrolysis reaction or a condensation reaction? Now, as you can see, there's less energy here than here. So in comparison between these two levels, we're going to start out with some energy here, and then we're going to actually have more energy at the end. So that means that we're putting in energy. Okay, so we're going to put in energy to make this product. Whenever we do that, we're building something, or we're building a bigger molecule. So if that's the case, then that must mean that it is a condensation reaction. If the opposite were true, this side would be much higher than this side, and that would result in a hydrolysis reaction. So again, this one, the energy is lower on this side than this side. And because it's lower on this side than this side, that means that it's building up molecules, which means it's a condensation reaction. Number 5, if the product was lactose, what would most likely be the reactants? So we've already talked about carbohydrates in the other videos, but if you remember, lactose does not have fruit in it. Okay, so if we have our 3 different types of monosaccharides, okay, we have our fructose, our glucose, and our galactose. Okay, you simply look for your keywords. So if you're trying to make lactose, clearly galactose has lactose in it. So all you have to simply ask yourself is, if it's one of these 3, or actually if it's 2 of these 3, does milk have fruit in it? Well, clearly milk does not have fruit in it, so you can eliminate that, and so we know that lactose is made from the combination of glucose and galactose. So, just to recap, in number 1, enzymes can best be described as molecules that require less energy to start a reaction. So in other words, they're considered catalysts. In number 2, we were talking about the different types of enzymes, substrate, products, and active sites. And then numbers 3 through 5, we were looking at this model here where it requires more energy without an enzyme than it does with an enzyme. So in other words, enzymes lower the activation energy and therefore does not require as much energy in order to start a chemical reaction. Okay guys, if you have any questions about Learning Target 6, please don't hesitate to ask. Thanks for watching the video.